And our next speaker is Miklós Koren, talking about Kezdi.jl, a data analysis package for economists.
I came in going, this was going to be unhinged. It was about as unhinged as I thought.
Please, the floor is yours. Let's welcome the speaker.
Hello, everyone. Thanks for coming. So my name is Miklós Koren, and I'm here to talk about Kezdi.jl, a data analysis package for economists. And this is joint work with Gary Attilakish, who's sitting here. So before we get started, just a few words about myself. I'm an economist by training, and I make it my mission to teach my fellow economists some computing best practices to help maximize the impact of their research. And I teach economics at the Central European University in Vienna. I'm also the data editor of the Review of Economic Studies. So that's one of the leading journals in economics. And there, my job is to review the code and data that the authors are submitting to the journal. So these are like the supporting materials for the articles. And I develop educational materials and software at my business, Coded Thinking. Now, you also get to know a person by kind of the company they keep, or in this case, the programming languages that they use. I've been using this programming language called Stata for more than 25 years. So by the way, Stata is a registered trademark of Stata Corp, LLC. I'm not affiliated with them in any way. This talk has not been endorsed by them, and I hope that by the end you will see why. Since 2003, I've been using Python. I use it, so Stata is for statistical analysis, plotting, model building, and model fitting. So Python I use mostly for data cleaning, web kind of work, web scraping, but not really for statistical analysis. And I'm, of course, a big fan of Julia, not surprising, by far my favorite language, and I use it for model simulations, but again, not really for doing any statistical work. So at this point, you might be wondering, what is this data that economists are so fond of? So, I don't want to extrapolate from my own personal experience, so I brought you some data. So if you look at the replication code, the research code that authors are submitting to our journal, then we get some data. So these are some of the best economists in the world, hopefully submitting some of their best research. And so we looked at, with Gary, we looked at 357 replication packages to see what do they do, what kind of programming languages they use, and how do they use them. So when it kind of comes to comparing programming languages, we can have some hard data. So the first thing to note is that economists don't really use Julia. Okay, so only about 3% of the replication packages have at least one JL script in them. Okay? So even Fortran or the various flavors of C are more popular among economists than Julia. Okay? So that's a sorry state of affairs that we have to kind of keep improving on. So the most popular programming language is Stata, and MATLAB is also very popular among economists. They are actually used for different purposes, often used together at the same time. Stata for cleaning your data, estimating your statistical models, and MATLAB to do model simulation. That's kind of a popular use case. So the our aspirations with this package is to move some of the people from Stata and kind of help them transition to Julia and give them a good user experience with that. There are similar efforts to move some of the MATLAB users to Julia as well, because I think for model building and model simulations, Julia is already really excellent. So what is this data? How does it look like? So if you look at the programming language, the code example on the left, these 5 lines, I would say it's pretty readable. So it's as a kind of very high-level data analysis language, it's very good for the user. It's very easy to get started. I don't really have to explain what it does. You load a data set called trade.dta, then you do some transformation on the distance variable. You want to enforce that distance can never be less than, say, 5. Whether it's kilometers or miles, we don't No, at this stage, there are no units in Stata. Then you do some log transformations, and then you run a regression with heteroscedastic robust standard errors. Okay, and on the right, I try to do it in pandas. Of course, I know that there are different APIs to work with pandas, and of course, there are like various excellent data wrangling APIs for Julia data frames as well. I just wanted to kind of give you a quick example of what an economist would see when they first come to move away from their familiar Stata scripts. And they would be annoyed by three things here. One is that there are lots of packages I want to load. So what do I load? Which packages should I turn to? And how do I load them? The second is, kind of, I think this data manipulation API is just ugly. I think it's very hard to read, very hard to maintain. I think this is much nicer. And the third issue is, suppose I have a statistical model. How do I estimate it? How can I make sure that it's the same type of estimation procedure giving exactly the same results as people are typically using in economics? How do I set kind of, what are the parameters to make sure that's happening? So we then dig deeper into what people use inside Stata and looked at the code that they write. And we found that the vast majority of the comments that they work on are data manipulation comments, or maybe some programming tools, but only about like 5% of the comments are actual statistical estimation comments. So when we thought to write Kezdi.jl, then we thought, well, maybe we should build something that implements all of the usual data manipulation comments, and then gradually we'll go towards exploratory data analysis comments and estimation comments as well. Because we want to make sure that our users are kind of happy with being able to do what they are typically doing. Now, so when we thought about this, okay, so let's write something that looks like Stata and can wrangle data, we faced a bit of a problem. So we got some feedback from the community that there are already a lot of good data wrangling interfaces in Julia. And I agree that they are excellent. There's DataFrames itself, there's DataFrames meta, there's query, there's Tidier data. So kind of why do you need a new one? So we were facing something like this XKCD comic when you have 14 standards and you set out to unify everything, and now the situation is worse than before, and your users might be more confused than before. But we realized that in our case, it's actually not, that's not the relevant meme to think about. I think a more relevant meme for us is the madman meme, where Julia users might feel bad for a Stata user. They are limited in all their options and all that. But as we saw in the data, most data users don't even think about Julia at all. Okay? So there is already this tool and this kind of interface that's pretty popular. So our goal is explicitly to have the Stata users. So the question is, what do these users want? And I think it was yesterday that Michael talked about happiness and speed. So economists don't care too much about speed because the data sets we're working with are not super large. So we thought it's going to be convenience, or another term for happiness, I guess, here, and correctness. And we want our code to be kind of easy to type, easy to read, easy to edit, and super easy to interact with our tool. But we would also like to make sure that our research results are actually correct and we don't get into embarrassing situation by finding weird bugs. So if you think of just kind of comparing languages, if you think of a language like Rust where you have static typing and memory safety, it's more likely to be correct, less likely to introduce bugs, but it may be less convenient for a research scientist who's not a programmer. Whereas Stata is like super easy to get started in, and I'm not saying it's incorrect. I'm saying it's easier to make bugs in Stata. Why? Because it makes a lot of default choices for you, which is actually leading to the convenience. And I'll show you some examples because we had to make decisions about these ourselves. But then if these default choices are made for you and you don't know them, that's where bugs can hide, right? And recently there have been a number of quite embarrassing retractions due to some of these hidden default choices. So with this in mind, we want to be mindful that there is this trade-off. So I don't think we should, there's like one language or one tool or one data wrangling library that solves everything. You have to be mindful of what your users want. So if your users are here, you don't really want to give them this, right? Because then they're not going to adopt the package. So we're going to move kind of the needle a little bit here and make sure that the Stata users are getting comfortable with Julia. Of course, they're going to get a lot more in Julia. And that's what we are trying to convince them. So let me kind of show you the features of Kezdi.jl. So here we have the Stata, the same code example I gave you before, and the same thing in Kezdi.jl. So the command syntax is almost exactly like in Stata. Literally, the only difference between the left and the right is the at symbol. So this is Julia code. This would not be correctly parsed in Julia, so we're using macros to ensure correct parsing. So that, if you're a Stata user, not a lot of things to change, so that's kind of convenient. Something to note, maybe for a Julia audience, is that nothing in Kezdi.jl is a function, or at least the functions are not part of our public API. Everything is going to be a macro, and we even have this row-level if clause. So basically what it does is it executes a command only on a subset of the data frame. And we are using the word if because that's what Stata users are used to. We understand it's very hacky, and we hope we don't get banned from JuliaCon in the future. But it's actually the power of Julia that makes it happen, because macros are parsed from left to right. So by the time the compiler gets to if, we have already eaten that up, and we have already consumed the symbol, so it's no longer there. But that's going to be expected by our Stata users. Other kind of convenience features, variable names are going to be referring to columns in the data frame as opposed to Julia variables. And there's auto-vectorization of function calls. So here log is actually a call to log dot. So kind of automatically vectorized, which is what the user would experience. There are going to be some exceptions that I'll show you in a second. So one thing to note here, and this is the Julia syntax, is that you load a data frame into a global scope, and then you operate on that global data frame. And so that is an example where it's super convenient. You can kind of get something working very, very quickly, but it is pretty much prone to bugs because you're manipulating a global state, and if you go for a coffee break and you come back and you have no idea what you did 10 minutes ago, then it can lead to weird bugs. So we're kind of keeping that functionality, but our suggestion is to only use it for like very quick iterative work. When you're quickly hacking together something, as soon as you have like 4 or 5 lines of code, you can write this in a more idiomatic way, and you can actually wrap your code in a begin end block. And then we have our own WID Macro, which is going to basically ensure that your code does not have side effects in the global scope. So that's kind of a more reproducible way of writing it. And of course, in Julia, we don't need to separately create these columns because the stats model's formula API allows you to just enter functions in there directly. You don't have to create them as variables first. Okay, so that's kind of a nicer way to do it. So what are some of the features that are kind of a given for Stata users but might look strange to this audience? My favorite is what I already mentioned, this if clause. So every single comment can operate on a subset of rows in the data frame. So here, let's keep the rows in the data frame for which distance is not missing. Or we've already seen this. Let's replace distance whenever it's less than 5. But regression or data aggregation can all use this if clause. So there are a bunch of, this is super useful for if you're, again, trying to get something done very quickly. There are a bunch of strange behaviors that we had to think about how to deal with. missing value treatment. I'll get to that in a little bit. And also type conversion, we're working on it. I think we can do the most typical type conversions, like integer to float or things like that, but with more complicated cases, we are still working on that. I mean, here, because the replace would just work on like a subset of rows, and so you would have a vector where some of the elements are, say, integers and others are floats. That's kind of, I mean, that's still the easiest part of type conversion. Missing values is another big topic. So this is where I was actually tripped up very often when I started to fully switch over to Julia and load my data set and start getting something, and I always got the error that, I cannot do this operation on missing. And so that was not super convenient for me because I was a newcomer. I had no idea how to do skip missing or pass missing or what to do with missing values in Julia, whereas everything just magically works in Stata. And so, and that's kind of what we adopted in Kezdi.jl as well. So for example, here we have this data frame on the right. What do you think the output of collapse sum x will be?
7.
Exactly. The answer is 7. So, and literally what we're doing is we're kind of skipping over the missing without explicitly saying it. And that's kind of, the user expects that, so that's good. You just have to have a simple line of code, and they get their expected output. Similarly, if we have the same data frame and we want to filter for x being less than 3, which rows would be kept?
That's a hard question. Missing is smaller than 3 or not? I don't understand.
And so this is actually something where we introduce something even kind of more convenient and maybe more bug prone, I'm not sure, than in Stata, because we decided that missing is always going to evaluate to false in an if clause. So that when you ask for x being less than 7, you're getting x being less than 7. What you're not getting may be greater equals, 3, less than 3. What you're not getting may be greater equal 3, or maybe missing or something. If infinity or not a number could be other magical values, but you can be sure that at least the rows you're getting are going to satisfy your condition. Now, so that's another example where this is all out on the, remember the trade-off? We are all out on the convenience scale. Users love it. But of course, real-world data frames don't have just 4 rows, but they have like many millions of rows, and you will not see that there are missing values there, and you get into problems. So we are actually thinking of making it possible to turn off this feature. So if you're not used to living with missing values, you can turn it off and on. We haven't implemented it yet, but that's something we think kind of to be able to move on that Pareto possibilities frontier, if you like. Now, so these were kind of things that look strange to Julia people. So what are some of the things that are totally natural to a Julia audience, but we hope will feel like a superpower to the Stata audience? Finally, there would be proper data structures. So in Stata, there are no lists or not a lot of data types. So let's say you have a data frame where you have a string with a comma-separated string, and you want to count how many different elements you have in that list. So then you can, so this is Kezdi.jl code. You can just split the text. It's going to be a list or a vector. And then you count the length of that vector. And the result of this is the number of terms that are in each of the cells, right? 2, 3, and 1. And so this would be totally magical. Of course, it's possible to do something like this in Stata with a lot of hacking. String processing, counting the commas or something like that, but not as real lists. Now note that there's length dot here, so I promised you that it's going to be auto vectorization. The reason here we are explicitly vectorizing length because we are telling Kezdi.jl that we want the length of an object evaluated in a single cell. Okay? Because otherwise length would actually be not auto-vectorized because it's a kind of an aggregation function, and it would give us the length of the entire data frame, or in this case 3. Another feature would be like user-defined functions. Actually, you can use any Julia function. So interoperability with other packages, I think, would be a great benefit for our audience. But you can write your own function. So you can wrap this counter into a function. In this case, this is operating on the cell itself. And the second, of course, is the same name, just a different method, would be summing across all the different rows, so all the different terms in the data frame. And then we can use the function. If we use it with a dot, it's going to be vectorized. So we are using the method that's defined on the element for text. And we've introduced a convenience function to say do not vectorize, DNV for do not vectorize. And in this case, because this is not vectorized, it's going to use the aggregation function. So it's going to add up all the different terms. Okay, so for example, this is an example where you can already enjoy the benefit of the simple syntax that Stata offers, but all the power that Julia can bring to the table. So let me say a few words about the roadmap, where we are and where we're hoping to go. So Kezdi.jl is now in general, but I would say it's in beta. So we're very much looking for feedback and suggestions and comments. It's working. It does what it promises to do, but there's a lot of things that are still not implemented yet. So we are going to be working on that. So what are these things? So in terms of statistics, we'd like to add a lot of functionalities in terms of fixed effect models, whether it's linear or nonlinear. These are very popular in economics. We use these type of models everywhere. And then there are often kind of some edge cases in how do you treat these fixed effects, but we're gonna be working on that. Output reporting after regressions would be important for the users, of course. Something that came up in community discussion is wall testing. So if you have like multiple constraints and you want to test your regression, whether say two estimated parameters are equal, that's kind of hard to do. There's no single package for that, and we're happy to take that on, for example, in terms of statistics. In terms of data wrangling, there's a number of low-hanging fruits that we just didn't get time to get to yet. Merging, appending, reshaping data sets. We clearly have to do these. Maybe improve speed of file input-output a little bit here and there, because we want to give users a good experience. So let me show you something that in terms of programming features we are thinking about introducing. I mentioned that we want to parameterize the risk tolerance of the user. Like, do you want Kezdi.jl to behave more like Stata, or do you want it to behave more like Julia? Okay. And so we think that it would be helpful to the user to kind of, make this choice explicit. So maybe we can use preferences.jl for that. And then an additional thing we're working on is passing variables into our begin end block into this local scope. So here, just give you an example. So here, when we say that this y variable, then in this formula, the y is not going to refer to a column in the data frame. It's actually a Julia variable, which could be a way to introduce for loops or any other, conditionals or anything that, regular programming tools to be relatively seamlessly integrated with code that has a totally different syntax than standard Julia syntax. Okay, so these are kind of the plans for the future. So just a couple of slides on the acknowledgements. So we got inspired to even start doing this by Tidier.jl and Karandeep Singh and all the contributors to Tidier.jl. We've been thinking about the problems for some time, but when we saw Tidier data come about, it's actually possible to do it in Julia. So let's try it. Johannes Böhm has a similar package, kind of working with almost data code in Julia, taking a different route. than we are. And here are all the packages that we are relying on right now. Of course, we're going to keep adding more when we add more functionality. And just maybe a final slide, like why the name? So why Kezdi.jl? And so this is to honor the memory of my late colleague Gábor Kezdi, who was a great economist and actually a great educator about data analysis. And so he has a textbook about data analysis for business, economics, and policy. And we kind of thought this is appropriate to name such a package after him. So we are very much open to your feedback, suggestions, and contributions on the GitHub repo. Thank you.
Thank you for the very nice talk. Do we have questions from the audience?
Please.
Yeah, thank you very much. It's a cool project. I'm also a big fan of the work that Karandeep and the team behind Tidier are doing, and you're doing something similar, so hats off, really nice. One thing I experienced when I did my undergrads in economics and also some courses during my master's was that professors who were kind of stubborn on still teaching us Stata and using Stata for everything. The reason they often mentioned was that, yeah, some of the things that we rely on in Stata, so certain panel models, panel regression models, they're simply not implemented in other languages. So my question is, do you think that this package could help translate some of these Stata implementations into Julia packages? So really go to the Stata source code and use these macros to make that process easier?
That's a great question. Unfortunately, I don't think the answer is yes to that, because Stata suffers from the two-language problem, as usual. So if you want your Stata package to be actually really fast and performant, you don't really write it in the Stata. There's actually a subset of, a different feature set of Stata, the matrix computing language, Meta, and that looks completely different, so we haven't touched that at all. So Kezdi.jl is not going to help with that. I think our goal is more facing towards the end users who are analyzing the data and not necessarily building packages. But given that it's much easier to build cool stuff in Julia, so kind of you could build a package in Julia and then integrate it into Kezdi.jl would be super easy. I think the porting, so it is true, and then the size of the community is of course very important. That there are a lot of new methods, and then when you develop a new method, you want to also show that it works, and then you want others to use it. So you write it in the language that you know, or you expect others to know. And so there's a big kind of network externality in this if you are economists thinking about this. So it's hard to change, the language of an entire community. We want to, make maybe a little bit of progress here. So we'll see how it goes.
Thanks. And
Any more questions from the audience?
Maybe I have one here. Yeah, you said that you wanted to attract Stata users by making a more robust tool. So do you plan to do some benchmark to prove it actually?
So robust,
That was your business case. You keep the convenience, but you make it more robust. So how are you going to prove it to the Stata community?
So it's a great question. What is the proven benefit to the Stata community? And so we have some benchmarks on speed, for example, and of course this faster. But I don't think that's the big benefit. I think the main benefit, other than of course Julia being free, I think the main benefit is the interoperability with other tools. So I think that could actually be an answer. So if that already in Julia there are other packages develop new methods, you can link to them more easily. I think that could be a big benefit.
Thanks.
just one follow-up. Have you already spoken to colleagues? Are some of them already using Kezdi instead of Stata, or planning to teach classes in Kezdi instead of Stata?
That would be awesome. So now we are already using it. So now, but basically, the first time we submitted to general was last week. So, but we're kind of hoping to go in that direction, because the idea is to mimic the. We've actually had discussions about this at the choice of programming language at CU when we are teaching statistics and econometrics. And a big argument for Stata is exactly convenience for users and the user experience. And so that's where we're hoping to get a foot in the door.
Thanks.
There's a question over there.
Hi, I was just wondering what the plotting libraries look like in Stata. What do people use? Do people draw graphs in Stata?
Yeah. So we didn't touch that yet. It's a pretty decent plotting lib. So the default, so very much in the same spirit. Like if you write scatter yx, you get a scatter plot that looks pretty good. Now, if you want to change some of the styling, it's very hard. But the default, get to your first plot, and I don't mean the compiling here. Just kind of the user producing their first plot is actually super easy, and it looks pretty okay. We didn't want to get into this yet, because you can, of course, do the data manipulation and use any of the Julia libraries to do your plotting.
I only ask because I'm the one who wrote Tidier plots, so I'd love to contribute if it's...
Yeah, we should talk more. I'd be super happy to talk about that.
Let's thank the speaker one more time.
Thank you.